2, 1.
Hello. Hi, Rajbir.
Hello, hi, Mika.
How are you?
I'm doing good. How are you?
Fine. Really excited about this webinar as well. So
Here we are back again.
yeah, here we are back again. It's been
every month.
yeah, it's been almost a month since the last one.
Yeah. All
But
right.
we are bringing some new stuff this time. It's gonna be more focused on gateway, on new drivers,
Okay.
new communication possibilities for
Okay.
Simumatik.
All right.
Kind of a technical one, I think. Let's see how much we go. We
So
dig.
this EtherNet is the new driver that we have now in Simumatik.
Yeah.
Okay.
Yeah. So it's two drivers we will be focusing today. This Ethernet IP driver, which is kind of different compared to the previous drivers we have been developing, and then we will be showing some applications that we recently have developed using the generic UDP driver. Okay, so just like a kind of introduction, we can show what we are gonna be dealing with today. So, regarding the Ethernet IP driver, I will show a very simple system, but as we will see here, this driver is really quick. Now we see it connected to codices. We will go through the details later, but it's a really quick driver, different approach compared to the other ones. And some of the beauties is that without changing anything in the model itself, neither parameters in the driver, you can connect any PLC to the model. And we will show that using codices and Studio 5000. So that's gonna be one of the parts, focusing on the Ethernet IP, and then you will show something related to the video we are seeing here.
Right.
Yeah. So it's
I'm going to work. Yeah, I'm going to work on the exercise that you created for the students in your last training.
Yeah.
So here, what you see is basically a machining center, and you'll see a moving robot, UR5, I believe, which is picking the object from one conveyor, putting in the machining center, and bring the final product to another conveyor. So this whole simulation is running via Python using the UDP driver. And if you see on the right side, this is my Python code for that. And within this Python code, we have implemented MQTT. So we have a broker running in our computer. So this broker can be usually anywhere. In this case, it's running on my computer. So the Python is sending the topics to the broker. And then I subscribe to this broker by Node-RED. So here, the gauge, which you see here, which shows 26 units, it's basically the number of workpiece finished by the robot. So now when it places this workpiece on this conveyor, this will increment to 27. So I'll be talking a little bit about how the system is running, how the connections are being done, things like that.
Exactly. And we have a course in the academy regarding what you are going to show, but regarding the Ethernet IP and connectivity, we haven't finished the tutorials. There will be definitely tutorials to connect this new driver to codices and Studio 5000. Write in the comments if you are willing to use other PLCs and you want to use this new driver, which is really powerful, so we can fix the tutorials later. So far, I think we have tested it with just Kawa PLCs, Rockwell PLCs, and codices compatible PLCs, and it works really, really well. So yeah, that's gonna be today. So it's quite a lot of stuff. We won't dig. We won't be going into much into the details, but I think regarding the Ethernet IP protocol, I think we need to tell a few things at least, because it requires. It's super flexible, but it requires doing some configurations in the computer, in the PC.
Okay.
So we can start with that. Just to tell, maybe while we are just starting with the webinar, that we just released a new version of the workspace and the gateway last week. We were forced to do some patches during the week to solve some minor issues, but it's also very good if we can get feedback from the users, because we are seeing a lot of improvements in the performance with the new workspace. Okay, so now the new workspace is using all CPUs or as many cores as possible in the computer, so it's performing way better with the physics and so on. And we have also improved the synchronization between the gateway and the workspace, so we can see that the latency will be between from 2 milliseconds up, depending the performance or the capabilities of your computer. So that is something that we like to hear always from our customers and users. So let us know what's your experience with the latest workspace. So that brings us to Ethernet IP. So let's explain this new driver. So you all know about different communication protocols we have been developing and using the last years, from OPC UA, which is the standard, we could say, in the industry, to native protocols like the S7 protocol for Siemens PLCs, the SIP protocol for Allen Bradley PLCs, and so on, ADS for Beckhoff. So the thing is that all these native protocols, the way we use them in the gateway when we develop drivers, is that when you start the emulation in Simumatik, these drivers will connect to the PLC. If it could be a physical PLC or just a soft PLC, and they will read and write memory address. Okay, that's how it works. Okay, we kind of access the PLC using the gateway. So the information that these drivers need is the address of the PLC, and which usually is the IP address, and the port and things like that. And then we tell, okay, we need to read this input memory, or we want to write in this input memory, and we need to read this output memory. This is how we do it. When it comes to Ethernet IP, now we are talking about industrial device field buses. Industrial field buses. What does it mean? In an industrial field bus, usually, not all of them, but they usually work with this master-slave topology. So you have a master, which usually is the PLC or the CPU, which want to communicate with several slaves and gather information and send information to them. So in a master-slave topology, it's the master, the PLC, which takes the initiative, or takes the first step and starts the communication with the others. Okay, sends telegrams and receives telegrams. So that's the main difference. When we are developing the Ethernet IP or generic Ethernet IP driver, this driver will be just waiting until the PLC actually is asking to connect, and is asking to give the input or in this case the input data, and will send to the slave the output data. Okay. So that's the difference.
So here the hardware is going to, for example, the real hardware which we have is going to imagine if it's actually a real Ethernet slave.
Yes.
Using Simumatik.
So the cool thing here is that in order to achieve the emulation of the slaves, we actually need to take over the IP address of that slave, or the IP address that slave will have in the reality. And I'm going to show you how we do that, in a moment. So as you were saying, the PLC, wherever it is a real PLC or a soft PLC, will have the address of the slave, which somehow Simumatik will emulate, and will start trying to make a connection, and once the connection is established, we'll share information. So that's the cool thing. This is the opposite way to what we have been doing with the native protocols and trying to read and write in the PLC. This time, with this driver, we don't do actively nothing. We just wait until the PLC tries to communicate, and then we answer with the same telegrams that the real slave will do. And that's the cool thing. Without changing anything in the, we don't need to change anything in the configuration of the PLC. The only thing we need to do is that we need to add the IP address of the slave to our computer, so Simumatik can take over it and can start answering the telegrams as the slave. And another cool thing is that this slave, in this case the Ethernet IP compatible slave, behaves exactly the same whatever PLC is trying to communicate. That's why, as we are gonna show soon, we can without changing the model, we are gonna make a Codesys PLC try to connect to our slave, and then we shut down the Codesys PLC. We will start a Rockwell PLC, and it will do the same. So we can have same model communicating with different
the same slave.
As long as we have the same configuration. So that's different. Another thing which is different as well is that in this case, because the slave doesn't really know where the input and output memory is located in the PLC, the addressing is a bit different. So we are not going much into the details, but when we address memory in the slaves, as we will see soon, we do it taking into account the local position of the input and output cards we have in this PLC rack, we call it, but somehow is representing a remote IO module. So we have a local addressing which will once transferred to the PLC, it could be another address. And I know this sounds like a mess, but we will see it soon with an example in Codesys. So it's different, and it requires changing a little bit the way of thinking when we use this kind of driver, but it's really, really powerful, and the latencies are really, really low. So these are very, very quick drivers. So I think I can actually jump and explain with an example what I was trying to say. So let's go full screen, and maybe I can hide us a little bit.
The camera.
So we go back to what I showed in the beginning. This is here we have Codesys, and we have the model. This is just a very simple model where we have we can have a short or quick tour. This is the regular what we call the rack PLC.
Rack PLC,
and the only thing I did here is that I changed this driver type to this driver type, the NF generic driver. And what we need to do here is to define which is the IP address that this remote IO module, in this case using this driver, will take over, or with which IP address will reply to the messages, and then the size of the input and output memory that will be sharing with the PLC. The size of the how many bytes we will be reading and writing from the PLC.
And this is the size in bytes, right?
Yes, this is the size in bytes. And I think the manual is already updated. We need to, as I mentioned, we don't have the tutorials, but they are coming soon. So how is this translated to the PLC? In Codesys, and this is just a simple project, we can do just set up an Ethernet or the Ethernet card for the PLC. We add the scanner, the Ethernet IP scanner, so now we can build a Ethernet IP network with this PLC. I'm using the control win, so you see it here, it's started. And now,
soft PLC.
And now here is where we say, okay, this slave will have this IP address, 150, and that's the same as we had in Simumatik. So those, of course, need to match. And then the difficult part to understand is the connection. This is how Ethernet IP compatible devices. They use some addressing path depending which part or how can I explain it? It's not very simple to explain, but basically you need to tell where from the slave you want to read and where in the slave you want to write. Okay, this is kind of you see here class, instance, attribute ID. This is a kind of object oriented approach. So somehow you need to set here some addresses. Usually this is in hexadecimal, so depending the hardware you are trying to emulate, you can read you need to read the documentation, and you need to set specific instance IDs for the input and the outputs. Okay, depending also the configuration and so on. It's different from manufacturer to manufacturer as well. So that's why it can become kind of confusing. But what we have done in Simumatik so far is that we don't care much about that. So actually, I'm not gonna save this. You can use the almost any instance number and it will work. What is important is that you define the size of the data you want to read and write. And here we are talking about 10 and 10, the same size that we had configured in Simumatik. That's the important thing. So summarizing, what is important is the IP address and the size of the data that we want to read and write. Okay? Output data and input data. Then the best configuration so far we have found this to work is using point-to-point communication. This is something that you can set up. And then using pure data for the format in the inputs, and this one, 32 bits run idle. That's so you know. Okay, the rest is not very important. Here as well, you can play with the RPI. This is how often you want the PLC to communicate with the slave. 10 milliseconds is pretty quick, but we will see that we can handle it. So yeah, this is the configuration we need to do. And if I just download this to the PLC, we will see that right now the PLC is complaining, and it's complaining that the PLC is not finding the slave, basically because it's not alive. What have we done in order to be able to emulate that IP address in my computer? Because let's say you want to emulate 3 different slaves with 3 different IP addresses. How do you do that? You need to open the settings in your network card. So I think I can guide you. In Windows, it's pretty easy. You can go here and you can go to network settings. Then you go to Ethernet. Then you go to the adapter options. And here, usually, your computer, if you check in the properties in your Ethernet card, when it comes to the Ethernet protocol version, here you can see that usually you have this check that you obtain automatically because you have a router in your in your organization or at home or wherever you are. Okay. In order to be able to assign more than one IP address to your network card, because now we need it. We need to have one IP address for the PLC and for me to reach internet and so on. And I want to have another IP address available in my computer, so this Ethernet slave will take over it. So in order to do that, you are forced to set the IP address manually. Okay. So basically what I did is that I had this set up to automatic, and I check my IP configuration. So as most of you know, you can open this and you can just do IP config. IP config. So you can see the different configurations on your different network cards. I check which was my IP address. I copy the settings, and what you have to do after that is to come here to the advanced tab, and here in the IP addresses you can click add and add a new IP address, which in its case, I added the 150.
Okay.
Of course, you need to be careful that no one else is using that IP address. Otherwise, you will have an IP conflict in your network.
Okay. Yeah.
But just ping it first and check. Okay, is this IP address free? Great. Then in that case, you can come here and include it. So let's say I want to have another IP address. We can open this. We ping, for example, if 188.151 is free.
You missed the
Yeah.
You put 198. Okay.
Yeah, it was 68.
160.
Yeah. So 68 is not answering. Then we could take it.
Right.
Yeah. So I could go back to here and just type that IP address.
Okay.
And now my computer will have both 150 and 151 on top of the one that I had by default. Okay.
Got it.
Which means that now I could have actually two Ethernet IP slaves in my model in Simumatik. Okay.
Is there any limit how many you can take?
I guess the limit will be how many. It will be how many IOs, how quick you want to transfer the information, and so on. We know from our customers that they are running several modules at the same time, and there is no problem. Okay, it's about the latency, the power, how powerful your computer is, and so on.
Got it.
So we don't have a limitation, soft limitation somewhere. It's more, I would say, the hardware limitation.
Hardware limitation. Got it.
So once you do that, basically you are ready to go. The only thing we need to do is to click play, and you see LEDs are blinking. Why are LEDs blinking here? Because I just have a code here. I'm gonna switch it off. Basically what I'm doing is super simple. I just take the inputs and add one and put it in the outputs. Why is this working like this? Because I just connected all the inputs to the outputs here in Simumatik. So if we check the connections, basically I take the input cards and everything is connected to the same output in the same port in the output card. So basically, and now anytime I can activate this, and we see how quick it is. Another cool thing in the new gateway is that we can see as well how quick is synchronizing the workspace with the gateway. And you see here,
that's nice.
2 milliseconds. So that's the limit, the lower limit we have set. Okay. In this system, the physics is not working out quite much, but as you can see, because we are communicating very quickly, the gateway is kind of working. Okay. But we have really good latency. So it's the minimum latency we can have.
But is this 43% a good number, or is it too much or too less?
Now that is from the 100%, how much is working, how much of the time the gateway is actually working.
Okay.
So you see, this is very quick, and at any time, if I just stop here, you will see that we get a timeout error in codices because it's
very nice.
It's kind of lose the connection with the device, and now we can with the hardware. For codices, there is no difference between this and the real one, and you see that automatically, depending on the PLC, it automatically tries to reconnect. Okay, so sometimes it takes some seconds until it reconnects, even if we click play, but it has nothing to do with Simumatik itself. As I say, when we click play, the driver just starts and waits until the PLC decides to, let's try to establish connection and try to send telegrams. And you see, it's kind of random, depending. Actually, maybe it's not that random, because I think here in codices we have an option to define how often we want to reconnect, if I don't remember. Somewhere here, I think, timeout. No, it's not this one. I think I have seen it somewhere. Maybe I'm there. I think I have seen somewhere that you have a parameter to say, how quick you want to try the reconnection.
Reconnect.
Here, auto reestablish connections. We don't know the time, but it tries. And if you disable that, then it's not gonna work the same way.
Okay, got it. Interesting.
Yeah. So
this you have tried right now with digital IOs. You can also do with analog, right?
Yeah. I mean, what
doesn't matter which IO it is.
No. And what I can show now is about this mapping thing, okay? Because we are always telling the inputs, the outputs, and so on. Yeah. The thing is that if we look to the model here, I'm gonna show it. How have we addressed the input and output cards in Simumatik? As you can see here, we wrote in the input card, this is going to IW0. So that means that these 16 inputs will end up in byte 0 and 1. And then the outputs in QW0. So it's the first output or the first byte and the second byte, or 0 and 1. Yeah. And so on with the analog inputs and then analog outputs. Yeah. But this is if we remember that we say that we will exchange 10 bytes
10 bytes
back and forth. What we are saying is in which position we are sending this input, digital input and outputs, okay? In which position on these 10 bytes. So basically what we are saying is that the digital inputs are coming in the first 2 bytes and then the analog inputs in the second and the third and so on. So, so this is in, let's say, in the Telegram we are sending back and forth. How are we sending it?
So I have a question. It's not dependent on how the cards are connected in the rack. It's dependent on the addressing in Simumatik.
Actually, with this approach we could connect the cards anyhow, but then use the address to tell in which position the memory will.
Got it. Okay. Interesting.
Yeah. So what happens, or what this is done like that, because if we go back to codices, actually we could say that the memory coming from this slave could go to IB100 and so on.
Right.
And this is something that just the PLC knows. The slave never knows where these 10 inputs and outputs are located.
Okay.
So, and you can, as you see, it's totally okay if I do like that. In codices.
Okay.
Yeah. So that's why.
I have
go ahead.
Sorry,
No.
Is it only possible to do this addressing in byte in codices, or can you do also words? Then it's like completely easy to map it.
No, this is the default one. So it's in bytes.
It's the default one.
Yeah.
Okay.
Then you need to. Yeah. The thing is that you know that IW50 is gonna be this one. So if you want to take the entire word, then you can do it that way. Yeah. But that is what we meant with the previous slide. That you need to consider that the addressing is a bit different. Okay.
Okay. Got it.
But once we have this up and running, and you see this is still going on because the soft PLC is running. I'm gonna stop the soft PLC here. The codices, you see that automatically this stopped. Now I have here prepared Logix Echo, which is the equivalent to Control Win, but for Rockwell PLCs. I'm gonna start also a CPU in my IP address, which is the 145. Yeah. Now we have the CPU up and running, and I am gonna show you the project in Studio 5000. Okay. The code is pretty much the same. I'm taking the inputs and adding one and putting it in an output. But let's take a look to the configuration of this Ethernet module. You can add it anytime. You see the configuration. We need an IP address and so on. But you add a new module, and let's see if the page pops up. Yeah. So I think if you just type generic. You see here generic. I think it's this one. Yeah. So you can add one of those. Yeah. And which is this one. And here you set any name you want. The IP address as we did. And here you see these are the assembly instances that I was telling in codices. In this case, it's not hexadecimal, but it's just integer value, decimal. And this is the size. So basically what I'm showing here is exactly the same configuration, but in this case is in this PLC, in the Rockwell PLC. So
okay, I have a question here.
yeah.
When you put assembly instance 101, what does this 101 means in your program?
Yeah, this is from the manufacturer of the remote I/O module. So depending which kind of cards you are using, in which mode the module is configured, even the manufacturer, these assembly instances may be different. Okay.
Okay. So if somebody is trying to do the same which you are doing, they can use 101 and 102 as well.
Yeah. And this is what I meant before. We are not taking into account the assembly instances, just the sizes. Okay. We want to keep it simple. Yeah. Keep it simple for now. So if we see that a PLC is trying to connect with the with the emulated remote I/O module, and the sizes are okay, we don't care much about the instances. Okay. Because I don't know, we don't want to go so deep into the configuration. It could be done, and there are other parameters like the manufacturer ID, the version of the module, and things like that. But we keep it simple.
Okay.
So just doing this configuration, we should be able to run. So again, we are running soft PLC. Let's check if I can connect to it. Let's go online.
Okay.
Yeah, it looks we are online. So now we have this module running, and it looks like it connected actually. So you see here the remote I/O is not blinking. Yeah. Let's toggle this. It happened directly. Yeah, and you see, without doing any change in the model, it was running since we left it with codices.
Exactly.
As soon as I started, the Logiseco CPU, of course, I already had download the project before this webinar.
Right.
But I could, I could stop. I think when you go there, if I go to program mode, it stops. If I go back to run mode, it will communicate. If you see it's running, if I reset, we will see the same as before with codices. This will time out, and after a few seconds, it says shutting down. I lose connection with the module.
Right. Okay.
Yeah, but I can click play, and again, this guy will try to reconnect, and you see everything, and it's super quick.
Wow. Yeah. Very nice.
This is super quick.
It's just like codices automatically reconnecting. Yeah. So I want to understand now. We have this application to have remote I/O in Simumatik. Where do you imagine users can use this remote I/O in Simumatik? Yeah. Do we have some ideas about that?
We decided to implement this driver because we have seen a trend in automation in general the last years that most of the companies are moving from a more located, I will say, centralized I/O system with a rack with a CPU, input cards, and so on, to a more decentralized, scalable solution where you may have a main cabinet just with the CPU, the switch, and then you have remote I/O modules.
Just IOs.
Yeah, remote I/O modules. The beauty using this generic driver is that we actually can reproduce that architecture, and you don't need to do any change in the settings in your project, because basically if you add those modules to your model and you connect the inputs and outputs through this, even if we are using the generic rack PLC, it represents a remote I/O module because it's using this driver. So basically of course it requires more work because we need to set all the IPs in our computer, but suddenly our computer will emulate all this architecture with several remote I/O modules, which makes everything more transparent, because the model actually represents more accurately the reality and actually allows you to test that you have all the IP addresses set up correctly, the sizes of the telegrams, and so on. And the main benefit is that you just have one program for in the PLC to use against the virtual model or the Simumatik model and the reality, and you don't require adding extra features or extra parameters in your project to allow communication. Like, I don't know, using a 7 protocol, you need to activate the PC interface or put get, and we know that TIA portal now wants to avoid doing that, or using OPC UA, you open actually a door to I don't know, others accessing the memory in your PC and so on. This is the safest way actually to do the virtual commissioning, we could say.
No, it's very interesting. I mean, the type of response you show, 2 milliseconds, it's amazing.
Yeah, it's crazy.
It's very close to realistic.
The RPI is set in the PLC, I think here in Studio 5000 as well. Here in the connection, you can set the RPI. So how often you come in. And I will say that if we increase this to 100, everything will go slower. Sorry if it could be that now this goes. It worked. I had some issues with the Studio 5000 crashing when you do what I did. But now what we see is that everything goes slower. Why? Because the PLC is communicating less often now with the Simumatik. So we are increasing slower the
And does it affect now the gateway percentage which you were showing before?
No, the thing is that the latency between the workspace and the gateway is still the minimum we can reach. That means that we have a really good connection between the gateway and the workspace.
Okay, this is the workspace and gateway. Okay. Very interesting.
Yeah.
I think I'm going to try this this example as well, and create some tutorials for our course, because we have some lessons in our gateway course. This will be another add-on, and I can also put this webinar there for someone to see as well. And maybe I can create some tutorials to explain again step by step how to approach using remote IOs in Simumatik.
Yeah.
Cool.
Yeah. So and again, if any of our users or customer is interested on using this driver, but you are using other PLC brand that we are not showing here, as I think even Omron has a very easy connection with Ethernet IP compatible devices, and I know almost all different brands have some card or to build a Ethernet IP network.
I will try maybe with Micro 850. I'm not sure if it works to have a remote IO device and try to link it to this one.
Yeah. So so we explain briefly how Ethernet IP differs from other drivers we have in the gateway. The difference that this is more is not that proactive than other drivers, but is more reactive, and it requires some setup in the in the computer to add the extra IP addresses we may need to reproduce or emulate these remote IO modules. I just show that it's not that difficult to configure these remote IO modules in the PLC. Actually, any of our industrial customer knows they are doing it every day. I mean, to build the real network in their projects. So basically it's the same. What you need to do in Simumatik is set the IP address and the size of the telegram, and that's all. It will do the magic.
Right. Okay.
And just that in most of the cases we have tried, the connection is lost with the slave, of course, when you stop the emulation, but as soon as you click play, it recovers. So and quite quickly. So we haven't seen any main issue with that. So I think that was the summary.
Are we also trying to build a Profinet driver for the same remote IO?
We have that in our plans. We don't know when it will come, but it's good also if someone is interested in that driver, just send us a comment or write it in the comments in this video, or send us an email, and it's good to know what people want us to prioritize.
Because I think there are a lot of Profinet IO remote modules as well, which were some Profinet. It's also interesting for Siemens modules. Okay, very nice. I'm very impressed with this.
Yeah, so now we if we go back to what we had in our plans, the next thing is to talk a little bit about this UDP driver, and I think you will take over now, and maybe you want to show us. Maybe you can start showing this course that you just release.
You mean the Python
the Python course, which basically we will be showing that, or what you are showing today is very related to this course.
Yeah. So we have this course, Learn Python with Simumatik. This is in our academy. If you go to academy.simumatik.com, you will end up with several courses. One of them is Learn Python with Simumatik, and it's a free course. Anybody can sign up and start learning. So what do you have in this course? This is just one example of the exercise to prioritize the cans, which cans should go first or not. And here, this whole production line is controlled using a Python program. So at the moment, we don't have much lectures, but we have 4 lectures in Python, which starts with Introduction to Python Programming. So if I go inside, and if you don't know Python, if this is the first time you're going to program Python, so here are some introduction and what is a variable, what kind of variables you can use in Python, some examples, some if-else statements. So just to give you some introduction how you can use Python. If you have used any other programming language, it will not be difficult for you to learn Python. It's quite related. So once you go through this basic exercises, then you will come to the second chapter, which talk about how you can integrate then Python with Simumatik. And in this case, we're going to use the UDP driver. So here is just one small example of our generic PLC test station in which we have the PLC. And in this lecture, you will understand how you can connect to the IOs of this PLC via Python. So here, if you see, I am controlling this conveyor with some objects on it using a Python program. And that's the Python program inside it. In the similar way, I'm going to show as well that we have a factory line, which is running also on Python, also via UDP driver using Python program.
Yeah, maybe what we can mention, Rajbir, is this in this screen. We have a GitHub repository where anyone, it is in the academy, it is described in the academy, but this is where you can find this class called UDP controller, which actually is the counterpart to the UDP generic driver. So this UDP generic driver is just a driver we did kind of for fun, because we wanted to leave the door open for anyone to send and receive data to the models and from the models in Simumatik. So basically, you send a JSON using UDP connection, and in this JSON, you send the variable name and the value, and you receive variable name and the value each time something changes in a PLC or whatever is sending data, which makes it super open, because to demonstrate that openness, we just develop a Python class which handles the connection and so on, and tells you when, helps you to define the variables you want to exchange and so on. And this is what is covered in the beginning of this course, basically.
Okay, so you mean this class UDP controller?
Yeah.
This is the driver which Python is using.
It's kind of the counterpart to the driver. The driver is in the gateway, and this is the equivalent in Python that can talk to that driver, but it's not rocket science, as I was saying. It's just if you want to, if you like, I don't know, C or C# or any other language, you can actually open a UDP connection with a specific port. And you will be talking to the UDP generic driver in the gateway, and you're going to start just sending and receiving telegrams in a given format. So if you read the documentation of that driver, which we have in the manual, it will be easy to implement. Even if you go to the repository of the UDP controller done in Python, you can very easily reverse engineer it and write it in any language. So it's really cool. We use it a lot just to play with Python, because we believe it's it's a really good way to learn Python programming.
To learn Python is more interactive than just printing on the terminal.
Yeah, I remember when I was in the university doing pyramids and things like that with the stars, and it wasn't so cool. But now we can be playing with the real stuff. We have that coffee machine exercise that as well, which is really cool, and we have an AGB as well. So we will be adding more exercises probably to this course, and it's kind of fun. The first part doesn't mean to be a complete Python course, but just for someone that doesn't know much about Python but has programmed before, it's enough. But you have a lot of courses out there to learn Python, in YouTube and anywhere. So,
and I think if a student program these two systems, his ideas will be much more open and wide, and he can play around with other systems as well using Python.
Yeah.
So here we have two examples. One of them is about the cans, which are coming in the conveyor line, and you can prioritize if you want green cans or blue cans. And these systems are ready to use. These are built in Simumatik already. You can just import the system into your workspace and start writing the code. The steps are already mentioned in these lectures. The interesting part is we have extended one of the lecture with MQTT. So you not only connect to the Python and write with IOs, you can also connect to the broker using your Python. This is what is happening in this environment here. So if I start the emulation now, and this is my Python on the bottom right, and I have to, maybe I can just put it here. Now, if you notice, the number of paths that are being produced, these are going to my dashboard. And my dashboard is running on Node-RED. So what is happening? The Python is taking the signals from the Simumatik, counting the number of workpieces that are completed, and sending to the topic, which we define in the Python, the number of paths completed. And then in Node-RED, we are subscribing to this topic to get the data. So the information flow is from Simumatik to Python, from Python to broker, from broker to Node-RED.
Exactly,
So this opens up the possibility for students to integrate an MQTT broker to their Python script, and then just do wonders. I mean, you can also connect to the MQTT running on the cloud, and then you can remotely share your data across different systems. And this is one of the examples. And this example is also public. You can just go to Simumatik and find PLC Challenge Factory, and then you can load this. An interesting part is right now you just see one line is running. Right? This is now a challenge for the student. They can integrate another line as well. So for that, they have to add an extra IOs into their Python script, and then add an extra topic to send it to the broker as well. So now if you see the Python script, if I go to the top, here is where you define the broker address. So right now, my broker is running in my computer. So you see this local host address, 127.0.0.1, and that's the port address. And this is the same address I take in my Node-RED. So this is my Node-RED flow. And if you see this topic, factory start machine, factory cell write counter. This is what we define here. So whatever topic you define in the Python, I subscribe to this topic into my Node-RED. And here you can see I have my server, localhost, and port 1883, which was mentioned here. So that's how we do the connection. And then there's some piece of code where you define how you can subscribe or publish the data to this topic. And it's just this standard generic MQTT code. And here is just how you define the variables. So these are the variables: PLC input 1, input 2, output 1, and output 2. This is the data type, which is words. And these are the variables which we take in Simumatik, where we have the PLC, just like we have seen for your system as well. And these variables, then we read in Python. We assign some tags to it.
It's like mapping them. We map them
like
somehow.
Mapping, we map them, right. And then just we write a small piece of code, which is like a while loop. And there we have our code. And once the code is solved, then we map the result to the output of PLC, which is going to Simumatik. And then you have a time sleep to run this loop again every 0.01 second.
It's basically
So
like a scan cycle in the PLC, but we read the inputs,
right.
we run the
Like
code and send the outputs. Yeah, and that's happening all the time.
Exactly.
Thanks to that UDP controller class, the transmission of the inputs and outputs is done transparently behind the scenes. Yeah.
Right.
And also mention that this piece of code is also included in the system as an asset.
Right. This is in the system, and this is also, I think, included in the course. Here is the explanation of the code. Yeah, and there are some challenges here. For example, there are 3 challenges which you put recently. You have to program the left line. So, oops, my system is out of memory. If you're programming the system, you can program right and left line together. So the challenge was, once you program the left line, right line, you have to program the left line. And then you have to avoid product collision, because when the product is coming from both the lines, they might collide. So we have to play around a little bit to see if they don't collide with each other. So I have to reload it because it's a heavy system, a heavy computer as well. So there are some challenges here which you can play around, and you can also make more KPIs. For example, here you just see one gauge which shows the number of production of units. You can also add another KPIs or another status of your system, if the robot is running or not, if the system is running or not, what's the production time of line 1 and line 2, if there's any alert or any failure, which you can highlight on your dashboard. This you can also include. So this might need a little bit of understanding how the node grid works, but internet is full with information. There's also some videos you will find of mine on YouTube you can also watch, and how the node grid works.
We can actually mention, Rashbir, that these components are part of a new library we are building. We have simplified components. You will see that those, for example, the conveyors, they just have one input or very few inputs, just to run them clockwise or forward, reverse, or using an analog signal. Even the sensors, they don't need to be fed with 24 volts and so on. These are some components that we have been developing way simpler than other ones, for the ones that do not want to focus that much on a real architecture in an automated system with all the connection relays and all this stuff. This is more quick to set up and simplified version of component. Even the robot cell, it kind of works manually. Or automatically. Sorry. You just tell you want to produce, and it starts producing.
So we don't have to do robot programming here. It will just automatically pick in place, because this is on backend already programmed.
Yeah, and that's also something quite cool, that it's possible to do these kind of things in Simumatik. You can build a robot cell and program both the robot and the PLC and the machine, or you can make a component which is the entire robot cell, and you can add the logic inside, and people can check this. It's a way more complex component, but this is a component that includes the entire logic of compared to a real or a simpler. That's super interesting, and that I think the new library is called Factory Components or something like that, and you will find. You will see that we are adding more and more components to that library. So this is a quite complex component.
So basically, there's a lot of Python going on behind, which is the chance for student to read the code and understand what's going on. So a lot of examples there inside to learn Python as well. Okay, cool.
Yeah, we really like Python, and that's why we wanted to use Python as well. The first place for this UDP generic, but again, this driver allows us to use any language, actually.
Okay.
So
that's great.
Yeah.
I will work on it as well, make some tutorials with this Python. Maybe we can have some more lessons.
Yeah, so I think we can kind of wrap up. It's just we almost did
it was an hour.
the hour. Yeah. Let me see. I'm gonna switch.
What's new in the pipeline? Which new drivers?
Let me see. We are working now in the vision cameras. So that hopefully it will be, we will have release during this year. Yeah. It's also, maybe we can mention it for the ones that are watching this webinar, that we are, if you are interested on being a beta tester for Simumatik, we actually are thinking about launching again the beta tester or beta tester program. And for that, we will, if someone is interested, you can send us an email or you can write a comment or whatever. We will reach you, and then we'll give you access to our the channel. What's called this chat? Discord. Yeah, the Discord channel where we can.
Discord.
Yeah. Okay. Tell about when we release something in the beta version, and so they can test it.
They can just test and let us know if there's any,
give us feedback and so on. So yeah, the team is working improving the performance of the workspace in the app side now. But we have a lot of new features in the workspace that will be released quite soon or during the autumn, like a undo feature that we know many people is waiting for. Autosave, cloning assemblies. We have a lot of things in the pipeline, and we will be releasing them regularly. So keep an eye in the banners we place in the app. Yeah. So we usually notify when we have a new feature. We create a new and we put it in a banner in the app, so you can read what's going on.
That's true. And what do you think is the next topic for the webinar would be interesting?
Yeah,
we were talking about Python as well, Python and OpenCV. This was the topic.
We didn't do that.
We didn't do it yet.
Okay, we can do that. We can do that webinar actually, because it's gonna be kind of introduction to what is coming with the built-in cameras.
Oh, is it?
Yeah. Because the idea is that we will have built-in cameras in the workspace, so you could render the scene in different ways and use these cameras to do vision systems and things like that. But we have a way to do that now already.
So this vision camera can also measure the product length and width and find out if it's bad or good.
Yeah,
is it like that?
I mean, it's gonna be what we want to do is that you will be able to gather pictures or video from the workspace, so you can treat it separately. And how you treat it is up to you. You could use a commercial vision system, or you could, as we were mentioning now, you could build something yourself with OpenCV. So the idea is gathering pictures from the virtual model, gathering pictures or video, so you can treat it and then use that data to guide a robot, tell whatever to the PLC, and so on. Classic vision applications. Yeah.
Okay. Oh, this is very interesting. So you can use any vision software to analyze this photo. And
it depends. It depends because sadly, not all vision software have the possibility to work in emulation mode or without the real camera. But I think I believe this is going to be a time question, because more and more, if virtual commissioning becomes a more popular thing, even vision camera manufacturers, they would like to have the option to work with what we call like fictitious, not fictitious, but virtual cameras.
Virtual cameras.
So pictures that are taken not from the real world, but taken from the virtual world, and process them with the same algorithms. I
think I worked with the camera. It was from the company SICK, or I don't remember.
Yeah, we have SICK, Cognex.
They have this software which can use just the image and give the output.
Exactly, yeah.
The software can do that. Just take the image, raw image.
Yeah, so
you don't need a camera.
No, the main issue could be that you need to drag and drop or select the image manually, which lose the automation part. But I think we tried many years ago some Cognex software, and it had a kind of way to trigger using pictures from the computer instead of the camera pictures. So you could kind of automatize even the...
And you can read the result as well from the software?
Yeah. That part was working as usual, using OPC UA or whatever to tell the PLC that which was the result.
That's nice.
But the triggering usually can be an issue because maybe you may not have, you don't have the real camera, how you tell, how you send the picture and tell the vision system to process.
Yeah, okay, then we will see maybe some software comes up.
Yeah, but I think once we have that in place, we probably will be playing with Cognes, Seek, or another software, and we will do some webinars showing how you could use Simumatik to do that. Yeah. Cool.
Okay, that was a great discussion.
Yeah.
Yeah.
So now we just run out of time. It's 3:00.
Yeah.
Let's say thank you to everyone watching. And
thank you everyone. And this webinar will be uploaded in Academy, so feel free to watch that again if you like.
Yeah. Thank you, Rajbir.
Feel free to subscribe and like us on LinkedIn and YouTube. Thank you, Miguel. Thank you for your time.
Thank you.
See you next